A swarm of small earthquakes struck southeast Missouri over the last 24 hours, the strongest of which was measured at a 3.0 magnitude and occurred around 12:30 this morning. The most powerful earthquake ever recorded east of the Mississippi River, which occurred over 2 centuries ago, may not yet be a closed chapter in geological history. While most earthquakes last only seconds to minutes, a rare type of seismic event challenges this. Scientists cite a slow slip event in Sumatra that spanned 32 years, eventually triggering a devastating quake and tsunami. If evidence confirms that aftershocks from the New Madrid earthquake sequence of 1811 to 1812 are still occurring, it could redefine our understanding of seismic persistence. The New Madrid earthquakes began in December 1811 with a violent shock in northeastern Arkansas, an area sparsely populated at the time. Yet, its impact was astonishingly far-reaching. The tremors were felt nearly 1,000 miles away in Washington, D.C., where White House chandeliers swayed, and as far as Boston, where church bells rang. The Mississippi River was briefly forced to flow backward, carving new waterfalls into the terrain. The town of New Madrid, Missouri, was obliterated, and the shaking continued intermittently until late January 1812, when the region experienced another massive quake near the confluence of the Ohio and Mississippi rivers. Geologists attribute these events to the New Madrid fault, which likely transferred stress to the nearby Reelfoot fault. 2 weeks later, another powerful quake struck, creating what is now known as Reelfoot Lake in Tennessee. The upheaval was so severe that the Mississippi River became a chaotic scene of uprooted trees and damaged steamboats. St. Louis, 160 miles away, suffered collapsed chimneys and structural damage, while tremors were felt as far away as Montreal, Canada, over 1,000 miles from the epicenter. Modern seismic activity in the New Madrid seismic zone reveals about 200 small earthquakes annually, and some researchers believe up to 30% could still be aftershocks from the early 19th century events. These aftershocks represent the Earth's ongoing effort to release built-up stress from the main quakes. While not all scientists agree that current tremors are connected to those historic events, the debate remains open. The underlying geology offers clues. The New Madrid region sits atop ancient rifts in the North American plate, remnants of a supercontinent called Rodinia that began breaking apart 750 million years ago. These rifts left weak zones in the crust, which may explain the persistent seismic activity. Using advanced statistical methods, geologists have found evidence suggesting that up to 65% of recent quakes in the area could be linked to the historic New Madrid sequence. This phenomenon isn't unique to New Madrid. For example, a massive quake in Charleston, South Carolina, in the late 19th century may account for up to 72% of the seismic activity in that region since then. Each location tells a different story, and the scientific debate about long-term aftershocks continues. Natural disasters remind humanity of Earth's restless nature. From the glowing peak of Mount Yeser in Vanuatu, continuously erupting for centuries, to Italy's Stromboli, known as the lighthouse of the Mediterranean, volcanic and seismic activity shapes life on Earth. These geological forces, whether slow building or catastrophic, tell a powerful narrative of our planet's dynamic history. Over 200 million years ago, Earth underwent a dramatic transformation through a series of 4 massive volcanic eruptions across a region spanning modern-day British Columbia and Alaska. These eruptions altered the climate, paving the way for the age of dinosaurs by creating a warm, humid world. Sediments from ancient lakes in China hold traces of volcanic ash and carbon spikes, revealing how these eruptions reshaped ecosystems and fueled evolutionary leaps. In a national park near Sydney, Australia, a phenomenon known as Burning Mountain has captivated the imagination for thousands of years. Deep beneath the Earth's surface, a coal seam fire has been smoldering for at least 6,000 years, making it one of the longest-lasting underground fires in history. This fiery giant, up to 30 feet wide and intensely hot, burns without visible flames. Instead, it creeps slowly, about 3 feet per year, consuming a vast coal deposit as it moves. First documented by a local farmer in the 19th century, who mistook it for a volcano, this fire holds significant cultural and spiritual meaning for indigenous people. They believe the blaze began from a widow's tear or the torch of a legendary hero. Scientists, however, suggest it likely started from a lightning strike or spontaneous combustion of coal exposed to oxygen. The fire heats the mountain like a massive oven, causing the ground to crack and collapse, which invites more oxygen to fuel its relentless advance. Experts believe it could burn for centuries or even millennia if left undisturbed. Efforts to extinguish such fires typically require enormous resources, including truckloads of water and liquid nitrogen, but success is far from guaranteed. Recent observations have revealed the fire approaching a cliff near a river. Its next move remains uncertain. It could intensify and erupt with flames or bury itself deeper and eventually die out. This natural furnace serves as a stark reminder of the power locked beneath the Earth's surface. If Burning Mountain is a testament to Earth's long-burning fires, the question of what would happen if all volcanoes on Earth erupted simultaneously is equally fascinating and terrifying. With about 1,500 active volcanoes globally, an event of such magnitude would unleash chaos far beyond anything humanity has experienced. Even if only the land-based volcanoes erupted, the consequences would be catastrophic. The explosions, lava flows, and pyroclastic surges would devastate local areas, but the real global threat lies in volcanic ash and gases. A thick layer of ash could block sunlight, plunging the planet into darkness. Without sunlight, photosynthesis would stop, leading to crop failures and a dramatic drop in temperatures. This volcanic winter could last for years, with ash lingering in the atmosphere for up to a decade. Volcanic gases such as sulfur dioxide and hydrochloric acid would mix with the atmosphere, causing acid rain that would harm groundwater, oceans, and ecosystems. The added carbon dioxide could also drive global warming, creating a dual climate crisis of freezing temperatures and scorching heat. Historical records, such as the 1991 eruption of Mount Pinatubo, show how even a single eruption can temporarily cool the planet. But a simultaneous eruption of all volcanoes would amplify these effects exponentially. Despite the grim scenario, the likelihood of all volcanoes erupting at once is nearly non-existent. Each volcano operates independently, drawing magma from localized sources beneath the Earth's crust. While some volcanoes, like Novarupta in Alaska, have shared magma systems, these are exceptions rather than the rule. Most volcanic systems are isolated, driven by distinct tectonic and mantle processes that cannot synchronize on a global scale. Even so, volcanic activity continues to surprise and fascinate scientists. Recently, off the coast of Vancouver Island, hundreds of small earthquakes have been detected beneath the Pacific Ocean. These tremors, caused by magma movement, hint at an impending underwater eruption nearly 3 miles below the ocean's surface. When it occurs, it will likely go unnoticed by all but researchers, as the magma will cool and solidify rapidly upon contact with the frigid seawater. Antarctica, often envisioned as a frozen, desolate expanse, holds a fiery secret beneath its icy surface. Scientists have identified over 130 volcanoes buried beneath the West Antarctic ice sheet, making it the largest volcanic region on Earth. Remarkably, most of these volcanoes, nearly 90%, were discovered only recently, in 2017. But the critical question remains: could any of these hidden giants erupt? Determining the activity of these volcanoes is challenging. While most remain dormant, Antarctica does host 2 confirmed active volcanoes, Deception Island and Mount Erebus. Mount Erebus, the tallest volcano on the continent, has been erupting consistently. Since at least 1972, Mount Erebus, known for its Strombolian eruptions, has occasionally hurled rocks from its crater. What sets Erebus apart is its rare persistent lava lake, sustained by a continuous supply of magma from deep within the Earth. This steady flow prevents the lake from solidifying despite the icy environment. Deception Island, the other active volcano, last erupted in the 1970s. Though currently quiet, it is closely monitored for any signs of renewed activity. Beyond these 2, Antarctica features feral vents releasing gases and vapors that sometimes create striking icy towers reaching heights of 10 feet. When it comes to supervolcanoes, these colossal formations dwarf typical volcanoes. Beneath them lies a vast magma chamber spanning tens or even hundreds of miles. Their eruptions can profoundly impact global climate, spreading ash and gases into the atmosphere. Yellowstone is one of the most infamous supervolcanoes, often sparking concern over its potential to erupt. Yellowstone's history includes 3 major eruptions over the last 2.1 million years, each more than 1,000 times the size of Mount St. Helens' 1980 eruption. The massive magma reservoirs beneath Yellowstone could fill the Grand Canyon 11 times. However, these chambers currently lack the necessary pressure and conditions for an eruption. Extensive monitoring of Yellowstone tracks seismic activity, ground deformation, gas emissions, and thermal changes. In March 2023 alone, 354 earthquakes were recorded in the region, including a swarm of 106 tremors. While such numbers may sound alarming, experts, including geophysicists at the Yellowstone Volcano Observatory, assure that this activity is routine. If Yellowstone were to erupt, the most devastating consequence would not be lava flows or local earthquakes, but rather the ash it would release. A supereruption could blanket a 500-mile radius with ash, disrupt agriculture, clog waterways, and even affect global climates. Ash clouds could linger in the atmosphere for years, blocking sunlight and causing temperatures to plummet, a scenario often referred to as a volcanic winter. Despite its fearsome reputation, Yellowstone remains stable. Volcanoes do not follow predictable timelines, and claims that Yellowstone is overdue are misconceptions. While monitoring continues, there is no evidence to suggest an eruption is imminent. The most recent Yellowstone supereruption, known as the Lava Creek eruption, left an indelible mark on Earth's geological history. This catastrophic event created the Yellowstone caldera, releasing an extraordinary amount of ash, rock, and volcanic gases into the atmosphere. More recently, scientists have uncovered evidence of two previously unknown supereruptions in this volcanic region dating back approximately 9 and 8.7 million years. The younger of these is now recognized as the largest recorded event in the Snake River Yellowstone volcanic province. Millions of years ago, the stage for these eruptions was set deep beneath Earth's crust. Heat from the planet's interior steadily melted rock, forming massive magma chambers filled with a volatile mix of molten rock, water vapor, and gases like carbon dioxide. Over time, the pressure in these chambers grew as magma accumulated, causing the ground above to rise imperceptibly. For thousands of years, these processes went unnoticed until the volcano began signaling its impending eruption. A year before the catastrophe, early warning signs emerged. Small-scale earthquakes increased in frequency, the ground warmed, and groundwater and surface lakes became noticeably hotter. If observers had existed at that time, they might have seen unusual steam clouds or felt the tremors. In the final months, cracks formed along the ground, releasing gases and sporadic bursts. The immense pressure beneath the surface eventually proved too much for the rock above to contain, triggering a colossal eruption. When the eruption began, a towering column of lava and ash shot into the sky, accompanied by a pyroclastic flow, a scorching avalanche of ash, gases, and molten rock fragments traveling at hurricane speeds. This deadly flow burned everything in its path, reaching temperatures of 1,300 degrees Fahrenheit. Over the following days, ash blanketed vast territories, collapsing trees under its weight and suffocating animals that inhaled its toxic particles. The eruption's sulfur-rich emissions reached the stratosphere, blocking sunlight and plunging the planet into a volcanic winter for years. Global temperatures dropped, disrupting ecosystems and agriculture. If such an eruption occurred today, the consequences would be catastrophic. A thick layer of ash could bury regions spanning Colorado, Utah, and Wyoming under 3 feet of debris. Even distant coastal areas would face disruptions, as ash clouds contaminated crops, pastures, and water supplies. Electrical systems would fail under the weight of the ash, and air travel would grind to a halt. Fortunately, experts agree that such an eruption is not imminent, allowing humanity to focus on other pressing challenges. Volcanoes are not limited to the famed Yellowstone. Around the Pacific Ocean lies the Ring of Fire, home to 3/4 of the planet's active volcanoes. By contrast, places like Australia and much of Europe experience minimal volcanic activity. However, one European volcano stands out: Mount Etna on the Italian island of Sicily. This towering giant, the most active volcano in Europe, has erupted around 200 times, with its most recent activity in August 2023. In Iceland, another volcanic story unfolds. On July 10, 2023, a young volcano emerged on a peninsula near the capital, Reykjavik. This eruption, marked by lava fountains and gas plumes, was anticipated by scientists who had recorded over 12,000 tremors in the preceding days. The eruption formed fissures over 1.5 miles long, from which molten lava spewed, igniting dry moss and creating an elongated cone, a classic volcanic shape. Iceland's unique geography makes it a hot spot for volcanic activity. The island is home to over 130 volcanoes, about 30 of which are currently active. While volcano tourism flourishes in this land of fire and ice, authorities prioritize safety. Extensive seismic monitoring and swift emergency responses ensure that visitors can marvel at these geological wonders without unnecessary risk. The 2010 eruption of Eyjafjallajökull highlighted the global impact of Iceland's volcanoes. Its ash plume reached an altitude of 7 miles, disrupting air travel across Europe for weeks. The period was far from ideal for air travelers, as powerful winds carried an enormous ash plume southeast toward northern Europe. Many countries shut their airspace for several days to ensure safety. Although the volcanic eruption officially began in March, seismic activity had been occurring since January of that year, giving seismologists early signs of the impending event. Iceland's youngest volcano has become a prime destination for visitors, with well-established infrastructure. Tourists can park in designated areas and embark on a 5-hour trek to a viewing deck. This spot brings them so close to the epicenter that they can feel the heat haze emanating from the crater. The site is especially inspiring at night, thanks to regularly updated hazard maps from scientists. Visitors who follow the rules can safely explore the area without risk. More than a week after the eruption began, part of the crater collapsed, sending lava flowing westward. The slow-moving lava was categorized as AA, a Hawaiian term for basaltic lava with a rough clinker surface. As it moves, pieces of the lava's brittle exterior break off, revealing the red-hot interior beneath. Cooler sections are gray or black, and the flow creates a sound reminiscent of shattering glass. Nearly a month later, aerial footage captured a rare phenomenon, a tornado forming directly over the lava flow. This occurs when high temperatures create a column of rising air that can spin under the right conditions. Scientists have observed similar events, such as during the 2018 eruption of Mount Kilauea in Hawaii. Iceland's volcanic landscape tells the story of its formation. The island sits atop the boundary between the North American and Eurasian tectonic plates. These massive rock slabs float on a partially molten layer beneath the Earth's crust. As they shift and grind against each other, energy is released, forming volcanoes. Iceland itself began to emerge around 60 million years ago as lava accumulated, eventually forming land. The island's oldest exposed rocks are 16 million years old. Constantly pushed outward as new lava surfaces, the island remains a hot spot for volcanic activity. A third of all basaltic lava recorded in human history has come from Icelandic eruptions. Vast fissure swarms cover 30% of the island, leaving only a quarter habitable. When Norse Vikings settled here in the 10th century, they were greeted by one of the largest eruptions in history, a spectacle unimaginable for those coming from regions without volcanoes. Today, Icelanders are accustomed to these events, though scientists warn that the region is entering an era of increased volcanic activity. The connection between glacial periods and volcanic eruptions is a topic of ongoing research. Glaciers, with their immense weight, can suppress magma flow beneath the surface. When glaciers retreat, the pressure is relieved, allowing magma to rise more easily, potentially triggering eruptions. This interplay highlights the dynamic relationship between Earth's climate and geological activity. Hawaii's Mount Mauna Loa, the world's largest volcano, poses a different kind of volcanic threat. Rising over 33,500 feet from its base on the ocean floor, it dwarfs even Mount Everest. Unlike explosive stratovolcanoes, Mauna Loa is a shield volcano known for its broad, low profile and fluid lava flows. Its last eruption in 1984 sent lava streams close to the outskirts of Hilo. Recent seismic activity beneath the volcano suggests that magma is moving, raising concerns about a potential eruption. What does the future hold for these vulnerable shores? That's a question we'll continue to explore together. Make sure to share your thoughts and subscribe to stay updated on the latest insights into our ever-changing planet. Thank you for watching, and as always, stay curious, stay informed, and take care.